Hey, this is Mr. Ford. I am doing the Algebra 1 Topic 3 review today. Remember, if you enjoy this video, give me a like and hit that follow button. In all seriousness, give me a follow. We're talking about several things today. We have the unit test coming up soon. The first thing we're going to talk about is domain and range. Okay, I want you to remember domain. So domain is how far left you can go and how far right you can go. And those are associated with the x's. Then we have the range, and that's how far up you can go and how far down you can go. Okay, and that's associated with the y's. Okay, so if I look at number 1, all of my x's, I'm just going to put them in order just so it's a little bit easier for me when it comes to the other stuff. I have -3, I have -1, I have 2, and I have 3. So those are all my x's. All my y's, I have -1, I have 1, I have 4, and I have 5. So those are all my x's, those are all my y's. So I can say I can write my domain and range like that. I can also write my ordered pairs in a table. So I have my x's are -3, -1, 2, and 3. Okay, my x that goes, or my y that goes with x is 5. My y that goes with -1 is -1. My y that goes with 2 is 4. My y that goes with 3 is 1. Right? So I said I could represent it in a table. I can also represent it, the right table for you. I can also represent it in a map. Okay, so I write them least to greatest and then least to greatest. So these are all my x's and these are all my y's. So all my x's I have -3, -1, 2, and 3. All my y's I have -1, 1, 4, and 5. I then draw lines from which x's go to which y's. So I say -3 goes to 5. I say -1 goes to -1. I say 2 goes to 4. And I say 3 goes to 1. And that's my map. Okay, and then I taught you something that says I can also represent them on a graph. Okay, so if I go -3, 5, I go left 1, 2, 3, and up 1, 2, 3, 4, 5, and I put a dot. I have the next order pair, -1, -1, so I go backwards 1, down 1, and I put a dot. Then I go to 2, 4, so I go over 1, 2, up 1, 2, 3, 4, and I put another dot. And my last one, I have 3, so I go over 1, 2, 3, up 1, and I put another dot. So that's me representing it on a graph. Okay, on to number 2. It says determine if the following relations, remember relations sounds like the word relationship, represents functions. And we think of functions as dating. So it says answer yes or no. Are the following functions? So we look at the first one. And I'm asking myself, does each x go with exactly one y? I say yes. So the first one is yes. Because all my x's go with one y. Now if I look at number 3, I look at -4 goes with 8. -3 goes with 1. 0 goes with -5. But -3 also goes with 2. So we got some trouble here. Okay? Just like you can only date one person in real life, your x can only be with one y. And our x is with 2 y's. So we say that is not a function. Okay, we go to number 4. Okay, a function says that every x goes with one y. Okay, but I could have multiple x's going to the same y. I just can't have one of my x's going to 2 different y's. So we're good on this one. Every x goes to at least one y, or to only one y. So we say that one is yes. Okay, this next one is called the vertical line test. So you put your pencil vertically on your paper, just like this. So if this is your pencil, wow, look at that pencil. Okay, you would put it on your paper. If it only crosses once, like this all does, so it crosses once on the graph there, once on the graph there, once on the graph there. If it only crosses over your pencil one time, it is a function. So in this case, my answer is yes. Okay, if you go to number 6, if we were asking, is it a function or not? If you did the vertical line test, you'll see that it passes through twice, so that wouldn't be a function. But that's not what number 6 is saying. Number 6 is saying, what's the domain and what's the range? So on this one, okay, our domain and range, you can actually literally see them. So we say x is between, so you write it like this, it's between 0 and it's between 5. So 1, 2, 3, 4, 5. So it's greater than 0, greater than 0, and it's less than 5, less than 5. Okay, so that's our domain. Our range, again, is the y's. So you're going to write it like this. It's between -1, -2, -3, -4, and up 1, 2, 3. So up 3. And that's my domain and range. Okay, my next one, number 7, says what's my domain and range? You'll see that there is this arrow right here and an arrow right here. This arrow says that this goes up forever and ever and ever, but as it's going up forever, it's also going right forever, because the further this way I go, the further right I'm going. Okay, so my domain on this one, it goes forever to the left and forever to the right. So I say it goes from negative infinity to positive infinity. So it's all real numbers, but the fancy way to write this is I draw a little r with an extra line through it. And that says all real numbers. In the same way, my range goes from negative infinity to positive infinity. So that's also all real numbers. Okay, so on to the next page. It says complete the function table and graph the line. So this one's pretty easy. All I do is I plug all of these x's into this equation. So the first one, I plug in 0. -2 times 0 is 0. 0 plus 5 is 5. Next one, 1 times -2 is -2. -2 plus 5 is 3. Next one, -2 times 3 is -6. -6 plus 5 is -1. The next one, -2 times 5 is -10. -10 plus 5 is -5. The next thing I'm going to do is I'm going to graph each point. So I'm going to graph 0, 1, 2, 3, 4, 5. Put a dot. I'm going to graph 1, 3. And I'm going to put a dot. I'm going to graph 3, -1. I'm going to put a dot. Then I'm going to graph 5, 1, 2, 3, 4, 5, -5, and put a dot. So I graphed my 4 dots right here. And my last step is I'm going to connect those dots just like so. I'm going to put arrows on either side of the line, because that's what mathy people like. They like the arrows. Okay, on to the next one. Okay, I plug in -2 into 3 over 2x, and I get -3. -3 minus 1 is -4. 3 over 2 times 0 is 0. 0 minus 1 is -1. 2 times 3 over 2 is 3. 3 minus 1 is 2. 3 over 2 times 4 is 6. 6 minus 1 is 5. So then I graph these. So -2, -1, 2, 3, 4. I put a dot. 0, -1. I put a dot. 2, up 2. I put a dot. And then 4, 1, 2, 3, 4. Up 1, 2, 3, 4, 5. And I put another dot. And then all I do, just like the last one, I connect my dots, just like so. And I put arrows, because I'm a mathy person. Okay, my format seems to be a little bit mixed up, but that's okay. We can do this thing. Okay, so it says f of x equals -3x plus 8. Find the following. So remember, when it's f of something, all I do is I plug that something into x. So I do -3 times -2 plus 8. So that'll be 6 plus 8, which is just 14. And that's my answer. Okay, the next one, negative 3 times 5 plus 8. So negative 15 plus 8 equals negative 7. Okay, the next one, don't get too confused or too stressed. I have two equations. Super easy. All I do is I plug in the first one into that, and I plug the second one into that. I get the answer for both, and I add them together. So when I plug this 2 into x plus 2, I get 4. When I plug the 3 into 2x, I get 6. So 4 plus 6 equals 10. So again, that was 2 plus 2, and that was 2 times 3. That's where I got both of those numbers from. Okay, the last one, it says f of 3. So 3 plus 2 times, plug 4 into the g equation, 2 times 4. Okay, so I have 5 times 8, and that's equal to 40, and that's my answer. Okay, on to the next one. It says, what are my zeros? Remember, zeros are where it crosses the x-axis. So I know I have a 0 at 5 and a 0 at 7. So I do squigglies. So my zeros are at 5 and 7. Okay, the next one. I have an equation, 1/4 x plus 5. And to find the zeros, I equal it to 0. And it's just simple math. I subtract 5 from both sides. So I have 1/4 x. If I have 5 cookies and I eat my 5 cookies, I have 0 cookies left. That makes me sad, but it's okay. I can make more. Anyways, 1/4 x equals negative 5. How do I get rid of divide by 4? Whoa, I multiply by 4 to both sides. So my 4's will cancel out. I'm left with x equals negative 20. Just like that. So that will also be a 0 for me. Okay, the next one, it says function transformations. Describe the transformation from f of x to g of x. Remember, we did this in the ed puzzle we did as a class. So I say, what is the difference between this equation and this equation? So if I was just looking at it, I could see that I just move it down 10. And that is the answer, so it's going to be down 10. Now, if I couldn't see that right away, all I would need to do is find my equation for this line, right? So I would say to find my equation, my y-intercept is 6, so f of x equals something x plus 6. Okay, so this says I go up 4, so I go up 2, I go up 4, I go over 2. So I know my slope is 2x. Okay, the next one, g of x. I know it crosses at negative 4, so it's something x minus 4. And I go up 4 over 2, so 4 divided by 2 is 2. And then I can just see that I simply drop down 10. So I say my answer is I went down 10. Okay, the next one, this is going to come in handy to graph your line. Okay, so I say f of x equals, okay, it crosses at 1, so it's going to be something x plus 1. Okay, and I say this goes up 1 and over 1, so I know my slope is just x. Okay, then g of x equals something x minus 1. Okay, so I have a dot here, and I have a dot here. So this goes up 1, 2, and it goes over 1. So I know my slope is 2x. So it says what changed from f of x to g of x? So I could say twice as steep, and it goes 2 down. Okay, when I say steep, I'm talking about my slope. So g of x is twice as steep as f of x, and it moves down 2. Okay, on to the next one. So determine whether the sequences are arithmetic sequences. If yes, sorry, coughing. If yes, identify the common difference. So we'll look at number 16. Okay, the difference between 5 and 10 is 5. The difference between 10 and 20 is 10. Uh-oh. I can stop right there. That makes me sad because that's not an arithmetic sequence. So I am just going to write, nope, that's not an arithmetic sequence. Nope, definitely not. That makes me sad. Okay, on to the next. It says, given the arithmetic sequence, find the next three terms. So I ask myself, how did I get from negative 19 to negative 17? And I added 2. How did I get from negative 17 to negative 15? I add 2. How did I get from negative 15 to negative 13? I add 2. Okay, then if I add 2 each time, I get negative 11, negative 9, and negative 7. Okay, on to the next one, number 18. It says, write the rule for the nth term using the recursive or explicit formula. Then find the 23rd term. Now, don't get confused by the nth. Nth just means you can pick any number in this sequence I want. So these are my first 4 terms, but I can tell you the 999th forever number. I can tell you the infinity number if I wanted to. Okay, based on a formula. The recursive or explicit formula is what we taught you in class. Okay, so the first one that we taught you is this. We said a sub n equals d times n minus 1 plus a1. So that's the recursive one that we taught you. Okay, we'll give you another option in class. But here's how you do it. So the first thing you're going to do when you get to a problem like this is you're going to write the difference between each number. Okay, so the difference between each number is minus 4. Minus 4. So my difference is minus 4. My first term is 33. So how do I do it? I write a sub n equals my difference times n minus 1. It's always n minus 1 plus my first term. Okay, then I see parentheses, so I know what to do. Coke truck driver or distributive property. So negative 4 times n, which is negative 4n. Negative 4 times minus 1 is plus 4. Then I have plus 33. So my equation is negative 4n plus 37. And then this says you plug in any number in the sequence you want, and I'll tell you what it is. So our number is 23. So I do negative 4 times 23, right? And that's equal to, let me put it in my calculator. So negative 4 times 23 is 92. So negative 92 plus 37 is negative 55. So the 23rd term in this sequence is negative 55. Okay, on to the next one. Every one of these, I add 5. So plus 5, plus 5, plus 5, plus 5. So I say my difference is 5. My first term is 11. Right, so here's my formula. A sub n equals my difference, which is 5, times n minus 1 always, plus 11. Okay, so I have 5 times n, which is 5n. 5 times minus 1, which is negative 5, plus 11. So my formula is 5n plus 6. My 23rd term, if I do 5 times 23, 115 plus 6 is 121. So my answer is 121. Okay, on to the next. It says determine whether the following scatter plots have a positive, negative, or no relationship. So if you're looking at this one, it looks like it has a negative line. So I'm going to say negative. If you're looking at number 21, there's absolutely no relationship at all. So we write no relationship. So no relationship. Number 22 says describe which line best fits the data shown. Okay, so here's some test-taking strategies. Okay, we know that this is around roughly what the line's going to look like. And we say that crosses around the 8, 9, somewhere in the middle maybe area. So we know absolutely it cannot be A. Let's make that a little bit more intense. It cannot be A. And it cannot be B, because that's negative 8. So this will be really helpful on the EOC or on the NWEA. Just eliminate the ones that make absolutely no sense. Okay? So letter C is negative 0.5x plus 8. Okay? Fair enough. D is negative x plus 8.5. So what I'm going to do is I'm going to graph both of these. This one I'm going to graph in red. This one I'm going to graph in blue. What I want you to decide is which one makes more sense. So I'm going to graph C first. Okay, so C goes up 8, and it goes down 0.5 over 1, and I put a dot. Down 0.5 over 1, and I put a dot. Down 0.5 and over 1, and I put a dot. Down 0.1 or 0.5 and over 1, and I put a dot. So this line goes right there through all of these dots, essentially. Okay, so that's my red line, or answer number C. My blue line, answer number D, goes up 8.5, and it goes down 1 and over 1. 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 Okay, so there's my line. I'll connect it. Okay, is essentially what it looks like. So I ask myself, which line makes more sense? Does it make more sense to choose the line that goes right through the middle of all these? Or does it make more sense to choose the line that goes underneath all the dots? And hopefully you say, I pick line C, or the one that's red, because that's the one that goes right through the middle. Okay, looking at the last problem here, our girl Tabitha. What a great girl. Let's draw her. So Tabitha. Okay, there's Tabby. She's so happy. She has long hair. Okay, there's Tabitha. Started working at a coffee shop, okay? So here's the coffee shop, okay? And she serves coffee at the coffee shop. In every hour, she makes $8.75. What a girl. Every 6 months, she gets a 40% raise. That makes Tabitha very, very happy. Okay, so Tabitha's happy. So it says, write a formula that represents her hourly. Write a formula to represent her hourly wage after each raise. So the difference is 0.4. The starting number, the hourly rate that she makes at first is $8.75. Okay, so we say the formula, A sub n equals D times n minus 1 plus A sub 1. And then I just fill it in. A sub n equals 0.4 times n minus 1 plus 8.75. I then distribute this out. So I say A sub n equals 0.4n minus 0.4 plus 8.75. And I do the math. Okay, so you pull up your calculator and you do negative 0.4 plus 8.75 and you get 8.35. So your equation is A sub n equals 0.4n plus 8.35. And that is your answer for number A, letter A. It's been a long week. It's almost Thanksgiving break. Okay, letter B says find her hourly wage at 3 years. So what we're going to do is how many months are in a year? 12, but it says every 6 months she gets a 40-cent raise. Okay, so what we're going to do is every 6 months, okay, but it's a year, so we're going to multiply it by 2 because there's 2 6-month periods in a year. So it's equal to 6. So we're going to plug 6 into this equation, right? So 0.4 times 6. Let's write it like this. 0.4 times 6 plus 8.35. So 0.4 times 6 plus 8.35. And I got $10.75. And that is your answer. Ka-ching! Anyways, thanks for watching.